Okay, so last we were talking about the hydrocarbons, and I we have what we call unsaturated and saturated. Saturated is where we have all single bonds with the hydrogen and the carbons. Of course, we know that hydrogen can never form a double bond. Say to the beast. Unsaturated is when we have a double bond or a triple bond between the two carbons. Okay, so we have amphipathic open chain. So that basically means that they're a single chain, or you could have branching occurring. And we kind of talked about how to go about that nomenclature last time. We have the cyclic ring. So we have the cycle alkane. Basically, it's all single chained. Again, it's saturated. So in that case, this guy is called amphipathic cyclic. And then we have aromatic. Aromatic basically has a benzene ring, or it could have multiple benzene rings. This is a benzene ring. And basically, a benzene ring, just a reminder, it is where you have a single bond and a double bond, a single bond and a double bond. You're alternating between the two. Okay. So this is unsaturated because you have a double bond. And so this is the symbol that we use for the benzene ring to make it easier for us to draw. And if you have any questions, go ahead and stop me. Okay, so we have the alcohols and the ethers. So when we go about naming alcohols and ethers, if you guys remember, we had talked about priority. And so far we had talked about alkyl halides. So those guys, they're going to end with an O, is the and they're going to be so, for example, fluoro. And they're often going to be prefixes. So that's the bottom of the chain. The next one is going to be ethers. Now, ethers are kind of odd, and I talked about this last time. There are two ways of naming ethers: the common way, and there's also the Iupac nomenclature, or the systematic way. Okay, so okay, so the common way for ethers. So let me give you the structure of an ether, the generic structure of an ether, and it's going to be shown on the other carbon. So basically, you have oxygen between two hydrocarbons. So the common way to name, yeah, there you go. So an example is this guy. This guy is called, since there's two methyl groups, so we would call this dimethyl ether. And that's the common way of doing it. Now, both ways are acceptable, the common way and the Iupac way. The Iupac way would be calling this methoxymethane. Okay, because that's a methyl, and then that's a methane. And so the longest chain gets the ane part of it. So let's say, for instance, if we had this guy, the common way to name this guy would be There's 1, 2 carbons. Let me draw that out. Let's see. That's the first carbon. That's the second carbon. And then over here, we have 1, 2, 3 carbons. So the longest carbon chain will get the ane part of it. So the Iupac way, this guy would be called oxy propane. Because that's the eth, 1, 2 carbons for eth, and then 1, 2, 3 for propane. The common way common name would be ethyl propyl ether. Okay. Do you guys get that? Okay, so let's see. Let's see if you guys have a clear grasp on that. So let's do. Okay. So what would be the name of this guy? I'm going to put a couple of them up there. I'll leave that one as an example. Okay. So I'll give you guys about 3 minutes to name each one. Okay. So you guys want to give, let's see. Bernice, do you want to try A? Sam, do you want to try B? Okay, so let's see. Let's count the carbons. That's 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. So yes, you are right. So it would be called butyl. The common name would be butyl hexyl ether. Sam, are you trying to talk? You have to unmute yourself.
No, I'm confused on how to do B. I know it's something with the hide. No, I'm actually confused.
Okay, so let's see if we can help you. So what is this structure here? Can't see what I'm pointing to, can you? This structure right here. What would that be called?
Like cycle or something like that.
Cyclo. So that's right. So you'd start off cyclo. Okay, now how many carbons does it have? So that's 1, that's 2, that's 3, that's 4 carbons. So 4 carbon would be called?
Tetra.
No.
Yeah,
this one doesn't obey the Greek prefixes. So it'll be called butyl, cyclobutyl.
How do you know when it obeys the Greek prefixes and when it doesn't?
Well, the Greek prefixes are used for getting the quantity of, like, let's say, of your side chains, or they're called substituents, things that are coming off your branches. So if you have 3 of the same branches, you use that to sit there and represent 3. When you're talking about the carbon chain, you always use, and I'll put this on the board again, it's meth for 1, eth for 2, bute for 3, prop for 4, oops, sorry, prop for 3, bute for 4, bute, oops, prop for 3, bute for 4, and pit for 5, hex for 6, hept for 7, oct for 8, known for 9, dec for 10, or des. Un dec for 11, do dec for 12, and tri dec for 13. Okay, so these here are all Greek prefixes, right? So we're used to those, but these, the first 4 aren't. Okay, so you want to remember that. So like propanol, you've heard of isopropanol?
Yeah.
So that means it has 3 carbons. Butanol or butane, butane has 4 carbons. So that'll kind of help you remember that. Okay. So this guy would be called cyclobutyl. And then on this side, it's 1, 2, 3, 4, 5, 6. So 6 carbons. Count that out. Those at home. That's 1, 2, 3, 4, 5, 6. So 6 is what? What would be the hex? That's right. So it's hexyl ether. Now that's the common name. Common name is fine. Like I said, you'll have the option of doing the common name or the Iupac name. So the Iupac name, again, you want to take the one that has the longest carbon chain. So this guy, longest carbon chain, gets the N, and the other side gets the prefix. So the other side is cyclo, butoxy. And then we'd call it hexane. This guy would be called butoxy hexane. So, Sam, do you want to help me out with the last one?
Mm-hmm. So for this one, would it be di, or is it
That's right. It would be di. Di what? There's one, there's two, there's three carbons. Oops. You got this. Look in the corner. If there's three carbons, then it's what?
Dipro.
Prop. Yeah, dipropyl. That's right. Okay. So let's see if we can fix that real quick. Dipropyl ether. Okay. So good. So you recognize that we had two of them, and then you use the Greek prefix to represent that two. Okay. The common name would be propoxy propane. Oops. I'm hitting all the wrong keys today. Okay. So are you guys having a lot of people over for Thanksgiving? No, just family? Yeah, we're going to have a small one this year. It's going to be just me and my sister. And probably my girlfriend and her son. So. Okay, so now let's talk about alcohols. And let's go with that priority list down here that I'm working on. And I'll put it in perspective if I can get it. Click on the right one. So I'd say this guy would be oxy. Oops. The example is methoxy. Okay. Let's see. Okay, so if we go up, our next priority is, it's the alkanes. So this guy has, it can, if it's a side chain, we use YL at the end. If it's, let me make some space. If it's the ending, put A and E. Okay. Okay, let's see. So Our next one would be alkenes. If it's a side chain, we put in, sorry, the next one would be alkyne, which is a triple bond. So this would be YN L or YN E. Give examples, so that would be pro. This guy would be methyl and methane. And Y. Then we have alkenes. Okay, now before that, we have alcohols. For alcohols, we put OL. Oops, sorry. Put hydroxy. Or we put OL. If it's the highest priority. Hydroxy. Or so let me give you an example. Okay, so for alcohols, we have an OH and a hydrocarbon. Okay, so this here is called a primary alcohol because it's on the main chain. And so since it's on the main chain, it's not a secondary structure or branching off the chain. It's considered a primary alcohol. Okay. So this guy would be 1, 2, 3. So this guy would be called 1-propanol. So this here is a secondary alcohol. Because it's coming off, it's branching off of the side chain. Okay, and then so we would call this guy 1, 2, 3, 4. So that would be butanol, and then it would be 2 butanol. Now, since alcohol has priority over alkanes, we use the OL instead of using the ANE. So if something else has priority over the alcohol, then we'd have to use that prefix and it would go in front. Okay, so do you guys want to give it a shot? Okay, let's do. Okay. So we'll do A, B. Oh, and we'll do. Okay. So how about Sam, you do the first one, and Bernice, you do the second one. Now count the number of carbons, Sam. So that's 1, that's 2, that's 3 carbons. Okay, so is 3F or is 2F? There we go. Okay, so it'll be 2 propyl. Oops. 2 propanol. Okay, Bernice. 1. No. Okay, so C, do together. Now that's 1, that's 2. Write down my numbers. That's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8, that's 9. Okay, and we have 2 alcohols coming off of it. Okay, so since I have 2, what am I going to use? I also have, counted from the other way, 1, 2, 3, 4, 5, 6, 7, 8, 9. So which numbers am I going to use? Am I going to use the red or am I going to use the green? That's right, the green. Okay, so now since I have two alcohols, how am I going to represent those two alcohols? Di, that's right. So I'm going to put, we have 9 carbon chain. What do I use for 9 carbon chain? That's right. So I'm going to put nona, nonane. And then I'm going to put the number, which is 3, comma, 3 diol. So we use the diol. So that lets me know that there's 2 alcohols. So that would be one way of doing it. Sometimes you'll see it without the E. Other times you'll see it with the E. But you'll see it both ways. I've seen it written in 2 different textbooks. Well, the same textbook, 2 different ways. The other way of doing it is putting the 3 in front of the nonane. Diol. Okay. Okay, questions? Okay. Good. So let's move on. I'm going to go ahead and erase all of this. Let's say we had a double bond. Okay, so this guy, 1, 2, 3, 4, 5. Now the alcohol has priority. So, sorry. Let's count it. Here's the first carbon, here's the second carbon, here's the third carbon, here's the fourth carbon. Since the alcohol has priority, we would start at the first, it would be on that first carbon. Okay, so the double bond is lower in priority than the alcohol. So it has second priority, right? It's not the most important, it's second. So in this case, we'd call this guy one, butene, 1, 2, ene, Oh. Oops. Or buta 2 ene 1. Oh. Okay. Questions? Okay. Okay, so let's see what else we can get into. Okay, so this is just giving you an example of what we talked about. Okay. Okay, these are just some ball and stick structures of alcohols. This is the ball and stick structures of ethers. The next on our priority list, the next in line is ketones. Okay, so for ketones, if it's a side chain, we use oxy. If it's a terminal chain, we use O. Okay. So let's see. Methoxo. And then propanone. Okay. Oxy. So let me give you an example. Okay, so ketones have this structure. So this guy is called a carbonyl group. So it's a double bond between an oxygen and a carbon, and then you have hydrocarbons either on the other side, or you could have a hydrogen. So an example of this okay, so we would call this guy count the carbons. Giving our functional group the lowest number. 1, 2, 3, 4, 5, 6. So this guy would be called the hexanol. We tell where that double bond is located at because it could be on any of the carbons except for that terminal carbon. Then it would be an aldehyde if it was on the terminal carbon. Okay, so let's see. 1, 2, 3. Okay, and okay, so we'll do A, B, C. So we'll do C together, but can you guys do A and B? Did you have a question, Sam? Yes. Okay, so we have a side chain. First thing that we want to do is find the longest chain. So, and we want to give our functional group the lowest number. So if we start here, so that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8, that's 9. We go the other direction. That's 1, that's 2, that's 3, that's 4, that's 5. That doesn't matter. It's the same either way, right? 5, 6, that's 7, that's 8, that's 9. Okay, so since we have this guy would be a methyl group, I'm going to circle it in black. That is a methyl group. Okay, so that's a side chain, okay, or a substitute, right? So in that case, we want to try to give that the lowest number since it doesn't matter which way we go, okay, because they both are on the fifth carbon. Okay, so then we want to start this since it's a side chain and it's only a methyl. It's only a one carbon chain. So then that would be methyl. And we have to tell where it's at. In this case, it would be on the third, giving it the lowest number possible since the priority group doesn't matter because it's 5 either way. And then it would be, we have to say where the double bond the double bond O is located. So then that would be 5. And then since it's a 9 carbon chain, what is a 9 carbon chain? No. So it's nonane. So it's nonanol. Okay. So 3 methyl, 5 nonanol. Okay. Now what about B? So we count the carbons. That's 1, that's 2, that's 3, that's 4, that's 5. So it's 5 carbons. There we go. Pentanone. Right. So it would be 3 pentanone. Okay. Questions? Concerns? Why 5? So we have to count the carbon chains. So that's 1, that's 2, that's 3, that's 4, that's 5 carbons. Do you see that, Bernice? Okay, so now let's do C. It's a little tricky. It's taking in all of the other ones, right? So we want to count and we want to make sure they give our priority group, the one that has the highest priority, the lowest number. So if we count this way, that's 1, that's 2, that's 3, that's 4, that's 5. Okay, so if we go the other way, that's 1, that's 2, that's 3. Okay, so it doesn't matter for our highest priority group. That's 4, that's 5. So who's second? Who has the second highest priority? The alcohol or the double bond at the end? The alcohol, that's right. So we want to try to give that it's the lowest, okay? So then we would call this guy so we have a 5 carbon chain. So 5 carbons. A 5 carbon chain is what again? Okay, so it's a pent, and it's going to be ene, and then it's own. Okay, now we have to say where the ene is at. Where's the ene located at? I don't know what's doing that. On the 3. Well, the oxo is located on the 3. The double bond is located on, it would be on the 5th carbon since the alcohol has priority. So then it would be the 5th carbon. Oops. Dash 5 dash ene dash own. Oh, this guy's 3rd carbon. I don't know why it's doing that. Okay, now the prefix for it, because we still have the hydroxy group that we're worried about as well too. So it would be 2 hydroxy penta 5-ene 3 own. Don't worry, I'm not going to give you anything that complicated, but I just wanted to show you that it can get a little more complicated when we have things that have higher priority. Okay. Okay, so let's move. Yeah, so the hydroxy, since the OH is on the 2, you use hydroxy to label that. So that lets me know that on the 2nd carbon, it has hydroxy. We wouldn't use alcohol because alcohol is lower in priority than the ketone. Does that make sense? Okay. Okay, so the next thing that we're going to talk about is alcohols. I'm going to go ahead and erase this down here. I mean, not alcohols, aldehydes. We already talked about alcohols. Aldehydes are have higher priority than the ketones. Okay, my screen is not behaving right. Hold on. There you go. Okay, so for aldehydes, okay, so for aldehydes, what we would do is, so if it isn't priority, if it doesn't have the highest priority, we use formal. If it is the highest priority, we use al. Okay, so the aldehyde, the generic structure for an aldehyde is a hydrocarbon and then on the side chain on the carbon is just a hydrogen. So like this, okay? So this guy would be called, let's move this over here. Longest carbon chain, let's count. So that's 1, that's 2, that's 3, that's 4, that's 5. So this guy would be called pentanol. I'm sorry, pentanol. And then it's usually a terminal chain anyway, so then you wouldn't have to put the 1, but you just call it pentanol. Okay? Let's see. So let's do this. 1, 2. Okay, the one at the very top of the screen. You guys work on that one? Okay, longest chain. One, 2, 3, 4, 5, 6, 7. Okay, so 7 carbon chain is called that's right. Peptan now. Okay, and that's it. Pretty simple. Yep. Okay, good. Okay, so let's move forward. Okay. Clear. Let's get rid of this. Okay, so we can also have what we call isomer. Okay, isomers are just basically the same chemical formula, but different molecular shapes. So this is an example of an isomer. So this is 1-butene, this is cis-2-butene, and this is trans-2-butene. So cis basically means the same. So like sister, cis. So these guys are on the same side. Trans means across. So these guys are across from each other. Easiest way to remember it. So these are an example of isomers. Now they behave differently because they are different structures. Okay, they're not going to behave exactly the same. Okay, so these are called geometric isomers. Okay, so they're the same chemical formula. They have a double bond, right? One double bond, one double bond, one double bond. So these are considered geometric isomers. Okay. Let's see. Come on. Okay, so our next one is carboxylic acids, and esters. Okay, so carboxylic acids, they basically have the O double bonded to the C, and then that's going to have an hydroxyl group on the side of it. So this makes it, it's going to make it the acid part of it altogether. So you guys are familiar with amino acids. So on one part of the amino acids, which makes up our proteins, so one part of the amino acids has a carboxy or carboxylic acid group. The other part has an amine group. And so that's why we call those guys amino acids. Okay, so in terms of priority, let's put these guys in perspective. Oops. Carboxylic acids are the highest on the totem pole. Okay, so they're at the very top. And the esters are just below them. So we have ester. So for esters, we have, it's going to be oxy, carbonyl, or we'll call it OH. Okay, so an example is methyl. And then for carboxylic acid, you can also add amines. Actually, amines are down lower. Down here. And we'll talk about those in a minute. Okay. And let's see, carboxylic acid. It has the highest priority, so we don't have to worry about that. If we did carboxy, and then this will be oic acid. And an example is ethanoic acid. Okay, so let's start off with the carboxylic acids. Okay, so one, two, three, 6. So we would call this guy, we count the carbon chains. 1, 2, 3, 4, 5, 6, 7. So this guy would be called, since it's a 7 carbon chain, we know a 7 carbon chain is hept. So it would be called heptanoic acid. Okay. Okay, what is this guy called? That's right. Let's see. So count the carbon chains. That's 1, that's 2, that's 3, that's 4, that's 5. So that is correct. So we know that 5 carbon chain is pentanoic. Okay. Okay, so let's do ethers. Sorry, esters. Okay, so the way we do esters is we count the carbon chains that are coming off. So this guy is that's 1, that's 2, that's 3, that's 4. And then on the other side, we have 1, 2, 3, 4, 5, 6. Okay, so the side that has the double bond and that carbon, so that's going to get the the O8 part of it. So then that guy is going to be called, we have 1, 2, 3, 4. So that would be butyl. And then it would be hex and so hexanoate. Okay. You guys see that? Okay, so let's give this a shot. Let's do Okay, go ahead and name that one. Okay, Long's chains, or our chains, count our chains. So that's 1, that's 2, that's 3. On the other side, it's 1, that's 2, that's 3. So what are we going to name this guy? Oops, I forgot one. 4. Sorry, that's 1, that's 2, that's 3, that's 4. Okay, so this guy would be called, so a 3-carbon chain. That's right. Propyl. Butanoate. Okay, piece of cake so far? Okay, so let's go on. Okay, sorry, there we go. Okay, Bernice. Well, watch the remainder in the recording, and then I'll see you after Thanksgiving. So have a happy Thanksgiving. Okay, so this is an example of carboxylic acids. We've talked about how to name them. So something that you need to know about acids in general, carboxylic acids, all carbon acids are weak acids. And so they only ionize a little bit. So that means they only break down into ions very little. So most of them are still held together. So they're not going to get that H plus going on. We've already talked about the ester, right? And so we talked about, so the first term is always the YL group. And that's typically associated with the O, and then coming off the O. And then the carbonyl group, that's your second term. So that's going to be the last one. Okay, so here's an example. This is an example of a carboxylic acid. This is an example of an ester. Okay, the last one is amines. So amines, they're going to be derivatives of ammonia, hence amine. And the way that we name them is so this is called this is a tertiary amine because it has, instead of hydrogens, it has 3 hydrocarbons. Okay. This here would be a secondary amine. Because you have 2 hydrocarbons. This here is a primary amine, since it only has 1 hydrocarbon. Okay. So let's say we have this guy. Okay, so we have methyl groups, all 3 sides. So we would name this guy trimethyl amine. If we have this amine, we name this guy ethyl methyl amine. Okay. Do you guys see that? Okay. So let's put one more up and then we'll see if you can name it. Okay. Okay, Sam, do you think you got it? Okay, so let's go ahead and count the carbons. No, because they're not connected. So each one is like independent. So that would be 1. This would be 2. This guy would be 1, 2, and then this guy would just be 1. Okay, so then we would call this guy, since there's 2 ethyls, it would be diethyl methyl amine. Okay, does that make sense? So you count each one independently. Okay. Okay, so these are examples of those amines. And you'll see these like on, let's say, soaps, insecticides, fungicides, things like that. So, dyes. Okay. Let's see. These are examples of amines. So here's ammonia. We know what ammonia looks like. So this is methylamine. This here is dimethylamine. So again, the nitrogen, you have the two methyl groups coming off of it. And this is trimethylamine. 3. So a tertiary amine, a secondary amine, and a primary amine. Okay. Let's see. Hold on. Sorry, I apologize. Last thing that we're going to talk about is the amide group. So the amide group, sorry. That is going to be right below the ester. Hold on. I just crashed mine. So. Okay. So the prefix would be carbonyl. The ending would be amide. An example is amide. Okay. So instead of, in the case of amides, instead of having the C attached to an O, we actually have it attached to the amide group. Okay. So, and then you will have your hydrocarbon. So it'll be R, C, double bond, O, and then you'd have the amide. Okay, so this here represents the amide. So when we talk about amino acids, this is the other end of the amino acid. Okay, so we have a carboxyl group on one side, the C terminal end, and then we have an amine group on the other side. Okay. Okay, so here are examples of some of the amino acids. Okay. So, and we have our carboxyl group, and then we have carbon, and then we have the amine group on the other end. Okay. So, and this forms what we call a dipeptide bond. Okay. So I'm not going to worry about naming those. What I want you guys to focus on is be able to identify the different different class of compounds. And then once you're able to identify the different class of compounds, it'll make it easier to sit there and it'll be easier to sit there and get the naming down. And also be familiar with the priority, the general priority. Okay. So this is just a summary of all the organic compounds and their generic structures, and they give you some examples and some of the names. Okay. So I'm actually going to stop here. I went over, well, technically I did, but I have a lecture with the inorganic nomenclature. So definitely take a look at that. That was for your lab assignment last week. And so I won't see you guys this week at all. So enjoy your Thanksgiving. And then I will see you guys next week on Tuesday. Okay.